second lesson in chapter 3 is about another special type of right triangle called a 30, 60, 90 triangle. Just like in a 45, 45, 90, there are certain relationships with the side lengths in a 30, 60, 90 right triangle as well. The hypotenuse, always the longest side. The short leg and the long leg in this triangle are different than in a 45, 45, 90 where the legs are congruent to each other. So in a 30, 60, 90, the short leg, always opposite the 30-degree angle. The long leg is always opposite the 60-degree angle. So let's talk about the relationship of the side lengths. If we know the length of the short leg, we simply double that length, multiply it by 2 to get the length of the hypotenuse. If we know the length of the short leg, we multiply that length by radical 3. We multiply x, the short leg, by radical 3 to equal the long leg. So in number 2, we notice that we have two triangles in the diagram, and I'm going to highlight just the triangle on the right, DFE. And that angle, DFE, is this angle right here. I'm trying to find the measure of that angle. So angle DFE in this triangle is 60 degrees. Number 4 says to find the missing lengths. So we're looking for side lengths B and C. So in this triangle, I know the short leg. So let's begin by going from the short leg to the hypotenuse. So to do that, I need to multiply radical 6 times 2. So that gives me 2 radical 6. To go from the short leg to the long leg, I'm going to multiply by radical 3. So radical 6 times radical 3 is radical 18. Now we can simplify radical 18. Radical 18 is the product of radical 9 times radical 2, which is the same as 3 radical 2. In number 6, I'm given the hypotenuse, and I need to find the values of A and B. So to go from the hypotenuse back to the short leg, instead of multiplying by 2, I'm going to divide by 2. Remember, the hypotenuse is twice as long as the short leg, so then to find the short leg, I simply divide by 2. I'm going to take 6 radical 3 and then divide that by 2. So 6 divided by 2 is 3 radical 3. From the short leg to the long leg, I multiply by radical 3. From the short leg to the long leg, multiply by radical 3. So to find B, I take my short leg, 3 radical 3, I'm going to multiply that by radical 3. So radical 3 times radical 3 is radical 9. The square root of 9 is 3. And 3 times 3 is equal to 9. In number 8, I'm given the long leg. short leg, I divide by radical 3. From the short leg to the hypotenuse, I multiply by 2. So the short leg is 12 divided by radical 3, and I'm going to multiply that by 2. Gives me 24 divided by radical 3. And once again, I'm given the long leg. From the long leg to the short leg, I'm going to divide by radical 3. And from the short leg to the hypotenuse, I'm going to multiply by 2. In number 12, I'm asked to find the area of each triangle. So once again, I'm going to begin with the formula for the area of a triangle, 1/2 the base times the height, 1/2 the base times the height. And in this triangle, I know neither the base nor do I know the height. So those are the values that I need to find. But because it is a 30, 60, 90, and I know the relationship, I can simply find A and B. So right now I know the hypotenuse is 12. From the hypotenuse to the short leg, I'm going to divide by 2. From the short leg to the long leg, I multiply by radical 3. So the area is 1/2 the base times the height. So in number 14, I'm going to begin with the area of a triangle. And I notice that in this triangle, I do not know the base, nor do I know the height. So I need to find those two values. But what I do know is I have a 30, 60, 90 triangle. So let's take a look here. In this 30, 60, 90, I know the side that is the hypotenuse. So to go from the hypotenuse to the short leg, I divide by 2. From the short leg to the long leg, I multiply by radical 3. So now I know the entire base of this triangle. Let's try that again. The entire base of the triangle is 20. And the height of the triangle is 10 radical 3. So my base is 20, the height 10 radical 3. in number 16, to solve for x, I first need to find the measure of this angle. And once I know the measure of that angle, then I can use the sum of the angles in a triangle equal to 180 degrees. So to find the measure of this missing angle right here, we need to begin by taking 180 degrees and subtracting 95, because what we know is that these two angles are supplementary. Together they add up to 180. So now I can write an equation to help me to solve for x. That equation would be 85 degrees for my first angle. My second angle is 5x minus 1. And the third angle is 8x plus 5. Together, all three of those angles equal 180 degrees. Number 17 and 18 is asking for the property used in the example. So in number 18, what I noticed is to solve for x, to get x equal to 4, I had to subtract 15 from both sides of the equation. So therefore, we say that we use the subtraction property of equality. Number 20 is asking me to find all the missing angles that are letters. So let's take a look at angle S. So to find the angle S, what I do know is that the three angles in a triangle must add up to 180 degrees. So I'm going to start with 180. I'm going to subtract the first angle, 65. Subtract the second angle, 42, which leaves angle F as being 73 degrees. Because I have a pair of parallel lines cut by a transversal, if I know the measure of angle S is 73 degrees, and angle R is alternate interior to angle S, then angle R is also 73 degrees. In a triangle, the sum of the angles is 180 degrees. So I can now find this missing angle measure. So beginning with 180, minus the first angle is 73, second angle is 65, which leaves 42 degrees. And then finally, to find the measure of angle W, which is supplementary to 42 degrees, can take 180, subtract 42, and angle W is 138 degrees. In problem C, angle that's 50 degrees is alternate interior to angle E. And we know that because we have a pair of parallel lines. We know that they're parallel because of these little marks right here. We have a pair of parallel lines cut by a transversal. And therefore, angle E is congruent to 50 degrees. And by the same token, this angle that's 65 degrees is alternate interior to this angle F. Therefore, F is also 65 degrees. So that leaves the measure of angle G. And the measure of angle G together with 50 degrees, 65 degrees, must add up to 180 degrees. So 180 minus 50 minus 65 leaves us with 65 degrees for angle G.